with Automation Direct here. In this video, we will cover the major features of the CLICK Programmable Logic Controller system. Let's get started. The CLICK PLC from Automation Direct is a new generation of inexpensive PLC components that were created with practical features and a very easy to use, compact yet expandable design. We like to say CLICK is the almost free PLC, and it is so easy to use, that's why we named it CLICK. The CLICK CPU is available in 4 basic discrete I/O configurations and 3 additional discrete I/O configurations with analog capability. The basic CPU includes 2 serial communication ports, while the analog version has 3. For expandability, up to 8 I/O modules can easily be added. The full-featured programming software is free and includes 21 easy-to-use instructions. 8,000 program steps can be programmed into the CPU's memory. All of this and more will be covered as we continue. In this next slide, we see the 7 different CPU modules that are currently available. Again, the first 4 modules listed are the basic CPU configurations with 8 digital inputs, 6 digital outputs, and various I/O combinations. The last 3 modules are the analog CPUs. They include 2 analog input channels, 2 analog output channels, 4 digital inputs, and 4 digital outputs, also in various I/O combinations. The analog input and output channels can be configured for either voltage or current. By itself, a powered CLICK CPU module can function as a complete PLC system, but there are situations where it would be nice to be able to expand, such as the ability to quickly add I/O points. Up to 8 I/O modules can be added to a CLICK CPU, allowing a total of up to 142 I/O points in a system. The CLICK PLC system is based on a rackless design, meaning no backplane. So additional I/O modules can be slid together and locked into place as shown in this illustration. The basic CLICK CPU module with 8 digital inputs, 6 digital outputs, and 2 RS-232 serial communication ports, again, is available in 4 different I/O configurations. Input choices include DC and AC voltages, while output choices include DC sync, DC source, and relay contact. The CPU includes a run-stop mode switch and numerous LED status indicators. The CPU also has removable terminal blocks for the I/O and the 24-volt DC power. As noted, the operating temperature range is 0 to 55 degrees Celsius. The analog CPU with 4 digital inputs and 4 digital outputs includes all the same features as the basic CPU, plus 2 analog input channels and 2 analog output channels, an RS-485 serial communications port, a real-time clock calendar, and battery-backed memory. The battery-backed memory feature for the CLICK analog CPUs requires an optional cell-type battery be installed. ADC's part number for the battery is D2-BAT-1. The analog CPU is available in 3 different I/O configurations. All 3 have DC digital inputs, and the choices for digital outputs are DC sync, DC source, or relay contact. We mentioned earlier that the 2 analog input and 2 output channels can be configured for either current or voltage. To clarify, you can select analog voltage or analog current for each analog I/O channel separately, but you must make sure you use the proper terminal on the terminal block when wiring for either an analog voltage or analog current signal. There are LED status indicators included on both the CPU and all of the I/O expansion modules. The LED indicators show the power, run, and error condition of the CPU, activity of the communication ports, and the status of all input and output points. The I/O modules include LED indicators for each input and output point and also have an indicator for power to the module. The LED indicators on the I/O points have been designated so that green LEDs represent inputs and red represent outputs. This feature gives the end user a quick visual to specific input and output points. The basic CPU module includes two RS-232 serial communication ports, while the analog CPU module has an additional third RS-485 communications port. All of the ports can be configured for Modbus RTU, while port 2 and 3 can also be used to handle ASCII data. Port 1 is designated as a Modbus RTU slave, is primarily used as the ladder logic programming port, but can also serve as a slave from a Modbus RTU master device, a CMOR operator interface, or another CLICK PLC acting as a Modbus RTU master. Port 2 can be used as a Modbus RTU master talking to a Modbus RTU slave device or another CLICK PLC serving as a Modbus RTU slave. Or port 2 can be used to make the CLICK PLC a Modbus RTU slave device controlled from other Modbus RTU masters. Or in addition, port 2 can be configured to send or receive ASCII data from devices such as barcode scanners, weigh scales, etc. Port 3, a 3-wire RS-485 communications port, can likewise be used as a Modbus RTU master, or a Modbus RTU slave, or to handle ASCII data in or out of the port. CLICK uses decimal addressing and starts as a numeric value of 1, therefore making it more convenient than using unconventional numbering systems such as octal. And for additional convenience, CLICK provides automatic Modbus addressing. No conversions to worry about. The CLICK CPU, I/O modules, and optional power supplies can be mounted by the use of 35mm DIN rail, or pop the mounting tabs out and use screws to fasten the modules to a mounting surface. As shown on this slide, there are currently 4 optional input modules available for the CLICK PLC system. The modules include DC voltage input in the 12 to 24 volt range, a lower DC voltage input in the 3.3 to 5 volt range, and an AC voltage input covering 100 to 120 volts AC. Some input modules have 8 points and others have 16 points. There are also 7 optional output modules currently available. The outputs cover DC voltage sink, source, relay contact, and AC voltage. Points per module vary by the different types. The CLICK CPU requires 24 volts DC. There are 2 optional power supplies available to power a CLICK system. The 0.5 amp power supply is ideal for a limited I/O configured system, while the 1.3 amp unit will provide unlimited power for any I/O configuration. The CPU can also be powered from a user-provided power source, or you might want to consider an ADC Rhino power supply for your next application. The dimensions of a CLICK CPU are a little over 2 inches wide by approximately 3 1/3 inches tall. The CPU, I/O, and power supply modules are all the same height. The I/O modules are a little over 1 inch wide, while the power supply is about 1 1/3 inches wide. All modules are approximately 3 inches deep, so in effect, it's a very small footprint. Getting your ladder logic program into the CLICK CPU requires a communications cable between your PC and the CLICK CPU module. Here we see the use of either a USB to RS-232 converter type cable, ADC part number EA-MG-PGM-CBL, or our older yet reliable direct logic programming cable, our part number D2-DS-CBL. Sourcing PCs with a 9-pin RS-232 type port is becoming more difficult, so using the USB to RS-232 converter type cable might be a better choice. All I can say in regards to the CLICK programming software, it's free. Download the programming software from the link shown here and give it a try today. To round out the CLICK PLC system, make wiring your application a breeze by using ZipLink modules and cables. Until next time, thank you for watching this tutorial from learn.AutomationDirect.com. Have a great day.